Okay, so problem 10, in this video I'm going to solve for volume, and in the next video we'll solve for surface area. Okay, not perimeter, but surface area. When we think about volume, if each square is 1 unit, that would be this side is 1, that side is 1, and that side's 1. So volume would be 1 times 1 times 1, which would be equal to 1 with units of like unit cubed. Okay. So volume is going to be 1 for 1 block. And that makes our math a little bit nicer. So if we do n and Tn, we have 4 shapes. And if we start counting, we can see that our first shape has 1. Our second shape has 1, 2, 3, and then 4 behind it. So it's going to be 3 plus 4, which is 7. And maybe let's just make another table here. And we'll just do some of our math, and that math might become useful. So this will also just be Tn. So this is 1, this is 7. Our third shape is going to be 1, 2, 3, 4, 5. And there's 1, 2 of those. So it's going to be 5 times 2 plus. And then the back one will be 3 by 3, 3 times 3. So it'll be 19. And then this one we have 1, 2, 3, 4, 5, 6, 7, and there's 3 of those. So it'll be 3 times 7, and that very back row is 1, 2, 3, 4 by 1, 2, 3, 4. So it's 4 times 4. So 21 plus 16 would give us 37. Okay. So this table is where we can start. It's one of the tools that we have. And I'm just going to erase all these dots. And so one of the tools we have is this table. And then one of the techniques we can use is let's look for common differences. So let's not look for a common difference, but let's just look for a first difference. If we look for a first difference, we find here it's 6, here it's 12, here it's 18. If we look for a second difference, I find here it is 6, here it's 6. So that tells me that my explicit formula is going to be quadratic. Okay. Useful, but it's sort of tough to take a quadratic formula and build it from this data. You can do it, it's a little bit of a challenge because we don't know where the vertex is or anything else. But that's useful. That might be a tool we can use. The second thing that we can do is we can start to look at building a recursive formula. And a recursive formula might be useful. And so one other way to make this table is I can look at making this table in a different fashion. And if I have n here and Tn here, this is 1, 2, 3, 4. We're at 1, 7, 19, 37. And then if I break this down, this is like 1. This is going to be 1 plus 6. This is going to be 7 plus 6 plus 6. And this is going to be 19 plus 6 plus 6 plus 6. And if we look carefully, we'll notice that this is my previous term. And here, we're adding 6 once, and then twice, and then 3 times. And so I can write this out recursively by saying that T1 is equal to 1, and Tn is equal to my previous term, Tn minus 1, plus 6 times n minus 1. Or 6 times n minus 1 is going to account for not adding 6 into my first term. We're not adding 6 up here. Okay, so that would give me a recursive definition, and if I wanted to, I could use this in Excel to go find out that the volume in step 43 is this. Okay. Again, we can get to a quadratic, but it's a little bit tougher, and I don't know if any of you will do this sort of on your own it's a tougher connection to make. But the one I want to think about, though, that will help us get to a recursive definition is I want to think about the volumes, and I want to look at the volumes a little bit different. If I look at the volumes of the full cube, what I'm sort of seeing is that there is the full cube, and then there's a cube that's being subtracted from it. So if I write these out that way, where here we have n, here we have the full, and here we have the removed, and here we have the final. Right? Let's see what comes up. We have 1, 2, 3, 4. The full is 1 in this case, the removed is 0, and the final is going to be 1, the full minus the removed. In the second case, the full would be 2 cubed, and the removed would be 1 cubed. And so that's going to be 8 minus 1, which would be 7. In the second case, the full would be 3 cubed, the removed would be 2 cubed, and so this is going to be 27 minus 8, which will be 19. And then we have 4 cubed and 3 cubed, which would be 64 minus 27, which would be equal to 37. Okay? So that's a different way to think about it. And here, we can draw some pretty nice conclusions. Right? This cubed is staying the same in all of them, and then the numbers are nicely related to n. So we could write it out this way. We could write our recursive as Tn is equal to n cubed minus n minus 1 cubed. Right? And that would be an explicit definition of this that is just coming from a visual noticing that it's one block that's being removed. Okay? And so when we go to do T43, we'll go, that's going to be equal to 43 cubed minus 42 cubed, and we'll find out that that's 5,419. Okay? So that's problem 10 for volume.